Okay, good morning everybody and welcome to our IMGS webinar on Zero to Snowflake. My name is Kieran Kirk. I am the General Manager with IMGS. With me today I have Didier Dote, who is our Pre-Sales Data Engineer.
Hello everyone.
And also working in the background we have Tanya McDonald, who looks after the marketing and also keeping an eye on us to make sure we're doing everything okay. Gareth Koning, one of our senior account managers. So, okay, so the first thing is just to remind you that we can take questions during the session. So you can type in the questions into the panel and the guys will collate them during the session and we'll review them at the end. So this morning we're going to have a nice introduction into Snowflake, which is our latest offering as a data warehouse designed and built for the cloud. So I'm going to give you a brief overview of the product and where it comes from, and then Didier is going to bring you through a very quick demonstration of how you can actually set up a Snowflake data warehouse, how you can ingest some data and take advantage of the Snowflake elasticity and scalability for speed of ingestion and analysis, and then I'll also show you some really cool features when it comes to data sharing. Okay, so I think everybody is online and we're pretty much about good to go. So first thing is IMGS. For those who aren't aware, IMGS, we provide a complete data intelligence platform based on our Talend, Snowflake and Power BI suite of solutions. So Talend is our ingestion and integration platform that helps us automate data flows. We can power data insights using both Talend and Snowflake, and we can visualize information with Power BI. Snowflake is the first data warehouse that has been actually built for the cloud. So it's a complete SQL database. It requires zero management, and we'll show you some of the features this morning of how that actually works. So removes the DBA overheads that you have with a normal on-premise or legacy data warehouse. Also with Snowflake, you can actually store all of your data, not just relational or structured data, but also semi and unstructured data. And again, we will talk about this morning. We won't have time to show, but Snowflake has the capabilities to ingest, analyze things like JSON and XML data, as well as normal relational information. Because Snowflake is built on the cloud, all of your users can access the data no matter where they are. And also, because it's the first data warehouse that's designed to take full use of cloud functionality, you can only pay for what you need. So if you need to ramp up to achieve, if you've got a big project or a big demand from your customers and you need a lot of usage, you can turn that on or you can turn it off when you don't need it. And naturally with Snowflake as well, we can provide secure data sharing. So allowing other users, partners, suppliers to access your data in a secure, governed manner. So Snowflake has a multi-clustered shared data architecture. So we have a centralized storage area where we store all the data in the cloud. This is also on, not just on Amazon, but this can also, you can choose your cloud storage, so you can choose Azure as well. And I think Google is coming down the line as well. Also, with your then, we have a computational layer, which can be used then for loading up data, for doing ad hoc analytics and for your development. And then we have the service front end, which allows you to optimize data structures, manage the information, set up transactions and security, and store metadata. And also, again, big part of all these services is that the level of automation they provide, the ability to actually cut down on the management of your data warehouse that you would have with a normal legacy data warehouse. And all this is done taking advantage of all cloud functionality so that we have instant automatic scalability and elasticity. Snowflake are a proven technology vendor and they're working with over 1,500 customers across the world. And again, you can see some really recognizable brands there, from Adobe to Hotel Tonight to EA Sports to Sony. Actually, I think it's involved on the PlayStation side, to banking with Capital One, where Snowflake has moved their data analytics to the cloud and really speed up the time to insight. Also, we're seeing a lot of customers now moving away from legacy data warehouse systems, so moving off things like Hadoop to actually take advantage of what the big data capabilities that you will get by using the cloud. So we're going to dive straight into Snowflake and start showing you the software. So the demonstration this morning is we're going to show you how we can ingest some data from both Amazon on the desktop, move it into Snowflake, and then be able to use both Talent and Power BI to analyze and ingest it. So the first thing we're going to talk to you about is that Snowflake is a complete SQL database. So it has broad support for standard SQL. It follows a full data management lifecycle, so you can do updates and deletions. It has the ability in the GUI to provide analytical and windowing functions, but it also has full transaction support. So full asset transactions, multi-statement transactions as well. All of this is driven around an enterprise class security with role-based access control and always-on encryption. So your data is very secure. If you're an experienced person with this SQL or Oracle, you've got full SQL support, so you can actually use the experience you had before. Or if you're like myself and you like doing things through a GUI, we actually provide a nice GUI front end where you can manage your database. So I'm going to pass over presenter mode to Aditya, who is, I can figure out how to switch to presenter mode, is change presenter, sorry, yeah, there it is, to Aditya. And Aditya is now going to show us, let me share the screen, yeah. He's going to show us what's on how the basic ingestion in Snowflake and setting up a warehouse. Thanks, Aditya.
Thanks, Karen. Thanks, and good morning, everyone. So we'll cut it short. As Karen said, that definitely we can ingest the data and use the analytics platform like Power BI or Talent to do the further analytics. But to start with, okay, let's basically just dive in and straight into the Snowflake just to see how it looks and what it does. So this is the cloud version that we have, and I'm using the IMGS account that I created kind of before the session. So as soon as you log into the to Snowflake, what you can see here is on right hand side you can see what you have is your worksheets. So basically here you write your SQL queries, like standard SQL queries, with which you can communicate with the database, which are on the left hand side, very standard format. On right top corner you can see like these are context variables which you can set for each of your worksheets, such as database and schema. For example, if you are aware of SQL queries, that you have to, for every query you have to type a database and select a schema, and then you type your table name and things like that. So these are the variables that you can set here. And on left top you can see these tabs are basically, these allows you to have access to all your databases, share warehouses, and you can manage those from here. So as you move along, we'll see more of it. And just to give you a brief about the data that we are using a TPC data, which is Transactional Performance Processing Council, and they provide data sets and set of queries which industry does benchmarking on for various databases and warehouses. So I am using one of the data set from there, and what we have is like just to make it shorter, we will be using three basically data sources. So what we have is like a set of customers who have ordered something. So we have a customer table and an order table. And again, those orders can have or might have multiple sub orders or part orders. So we have a line item data set as well. So basically we'll move along these three files. So let's start with building a database. So I'll use GUI for this, and if I click on the database tab, you can see that quickly from the database, from the GUI, you can create a database basically. So I am giving it name as TPCHDB, which, and let's give a comment. So basically these are the metadata that you can attach. So just a standard comments if you would like to give. So stores TPC data or decision support data. So let's do finish. If I go back to my worksheet, so hopefully we should be able to see the database created. Let's highlight it. So you can see that instantly the database is up, and what you get is two schemas, information schema and public schema. So again, information schema is the standard one that you get, which will hold your metadata and all the objects for your database, and public schema is where we will be going to, create our table and hold the data in it. So now the database is ready. Now the next thing is we have to get the data into a Snowflake cloud, basically. So to do that, what you have to do is, these are my databases. This is the database that we have created, TPCHDB. So let's select it. So again, so now next thing we'll do is basically we'll kind of get our data into the cloud first. So for that, I am creating a schema into my TPCH database, which is, say, call it stage. So I can go to the schemas and I'll create a stage schema. So the reason I am creating it is basically because I want to link my all the source data with this stage schema. So now in order to ingest data into Snowflake, or to get data into Snowflake cloud, what you have to do is you have to go to the stage. When you click on this plus, so basically Snowflake provides three possible ways with which you can get your data into cloud. So either you can link your Amazon S3 bucket, or you might have Azure Blob Storage, or Snowflake also provides a Snowflake hosted internal cloud bucket, where you can just get your data from anywhere. Like you might have it on your desktop, or you might be storing in your mainframe or some other databases on-prem. You can just get those data into Snowflake using the functionality that I'm going to show you next. So what I'm going to do is, now I have few data on my Amazon S3 bucket. So I want to link the folder on my Amazon S3 bucket which holds the source file with the stage schema that we have created. So let's do it. So I'll click on next. I'm giving a name to the stage is S3 orders. Now S3, just the naming convention that I've decided, S3 is my Amazon S3 bucket, and orders is the file or the source data that I want to get into Snowflake. I'm linking this to my stage schema that we have created, and IMGS demo data / orders is basically the orders folder on my IMGS demo data bucket that I have on S3. I'll quickly provide the access key and the secret key so that I can just connect to the Snowflake bucket. I think we are good to go. If I do finish, you can see now. So basically what we have done is we have linked our stage schema to our Amazon S3 bucket, which have an IMGS demo data bucket, and under which we have a folder called orders. So if I go back to my worksheet, and Snowflake provides a list command. So this is the basically link that we have created. So if I can list it, if I can run this command, what I should see is so if I run it again, 3 orders. So once let me just check what error is it. So I will basically quickly, I think I have to select a database from here because there is no database defined. So basically this worksheet, we have to define a context as to what context we are using it. So TPCHDB is our database and stage is the schema that we are using. So I think if I can able to run it, I should be able to do it. So yeah. So basically to run any query in the worksheet, what we have to do is we have to define or basically set a context here as to in which context we are running. So if you run it, so you can see that these many csv.zip file, I have almost 53 files I have on my Amazon S3 bucket. So still it's on my bucket, but we have linked this to our Snowflake, and we can just access it from here. So you don't have to go into your Amazon S3 bucket and see how many files are there. So now we have linked the file. Now what next we'll do is we'll create a schema in our public. We will create a table schema, or we'll create a a blank table, empty table into the public schema of our TPCHDB database, which will hold the orders data, which is still on our Amazon S3 bucket. So if I do the run, so again pretty quickly we have, I think the orders table is here, and you can see that it's empty. So then now next thing is we want to. So the next thing basically is to load the data from the CSV file into our orders table. To do so, what Snowflake needs is a file format, so that the system knows as to what's the format of the source file, so that basically it can manipulate it and read the file. So again, what I'm doing here is I'm going to the databases. I selected TPCHDB database, and I'm going to file format, and I'm creating a file format, say orders file. Schema, I want to link it to state schema. File again. So basically, what we are defining a file format for the source file, and format is CSV. Compression mode is auto. So these are the standard kind of parameters that you get when you are working with CSV file or any structured file. So let's quickly select this one. Like my fields are double quoted, so I know that this is the data that I have in source. So let's finish it. So now we have defined the file format basically. So now Snowflake knows the schema or the structure of the source file. Now we'll simply upload the table. So I go back to table, and I have orders table created here. If I click on it, so it gives me an option to load table from the GUI as well. Again, you can do it using SQL queries, but let's do it from the front end. So if I go and select the load table, so the first thing it asks me to select a warehouse. So now what in Snowflake, what warehouse is your computing resource, or we call it basically virtual warehouses. These are the computing nodes that are required to basically physically migrate the data from our Amazon S3 bucket into a table that is there in the Snowflake, and basically to perform SQL queries. So you need to have a computing resource that can do that task. So I'll quickly cancel it, and let's create or assign a computing node or computing resources to our database. So what I'm doing here is I went to the warehouses and just create a virtual warehouse called TPCHDB_warehouse. Now the warehouse or the computing power comes in t-shirt sizes, we call it. So from extra small to 4x large. So basically these are the computing nodes that you are assigning to your virtual warehouse or the computing cluster. So let's start with the.
So have we used any computation yet?
Yeah. So again, Karen, this is something really interesting, that till now we haven't basically used any computing resources. It's just that we were defining the metadata.
Yes.
So again, since it works on the basis of you will pay based on your computing resources that you utilize. Yeah. So till now, since we are defining the metadata, there was no need to use a computing or the computing resources. Yeah.
Yeah. So we haven't spent any money in the in the 10 minutes we've been going. Yeah. Well, that's good. And it's only when we start ingesting data or doing analytics where we're calling the computation.
Yeah.
That so you use your, and if the system is sitting idle, it's sitting idle, and there's no charge. Yeah, that's very good.
So let's create an extra small one. So, and again, what Snowflake also provides you with the functionality to auto suspend it and auto resume it. So as Karen already mentioned, that if you are not doing anything, we are sitting idle, so it can automatically suspend your warehouse, so you are not being charged, And again, whenever it finds an activity, it can automatically resume it. So basically, you are kind of allocating computing resources on the fly. You don't need to switch off or make sure that your database or warehouse is kind of is idle or not facing more traffic and something like that. Let's finish it. So again, you can see that basically what we have done is we have assigned a computing node or the compute cluster to our database that we have created. Now let's load the table. So we'll use the warehouse or the computing node that we have created. Source file, we are the files that we have is on our Amazon S3 bucket that we have already kind of linked. I'll do next. File format is the one that we have just created, as I showed you earlier. If you can, and these are the basically load options that you get. So as to what you want, if an error occurs, you want to load it, you don't want to load anything, or you want to skip the error once. So we'll say that stop loading, roll back, and return the error if we find a passing error. Let's load it. So now what Snowflake doing in the background is it's kind of uncompressing the source file. Finding the best optimal way to store the data into the table. It basically loads your table and it again compresses it and also generates some statistics. So what it does on the background is the DBA related tasks. So you can see the another good feature is that you don't have to worry about indexing or partitioning of your database to make it run faster. Snowflake takes care of it, and yeah, it again compresses it and stores it in the most optimal way for you, and all in the background. So you don't have to worry about all the all the management or the DBA level, most of the DBA level tasks that you perform on your traditional or the conventional warehouses that you have. So let's go back to our worksheet. So if I can just preview the data. Okay, so again, we haven't allocated any warehouse to a worksheet. So quickly what I'll do is I'll select a warehouse that we have just created, and schema is public. So again, since we are doing a select command here, since I was doing the preview, so it's basically a select command. So again, only when you are getting the data, working with the data, you need to have computing resource. Otherwise, if you're working with metadata, there's no computing resource that's been utilized. So if you can preview the data, you can see that these many rows we have loaded. So if I can just quickly refresh it. So orders table, now it says that it has 15 million rows. So let's
15 million rows.
Yeah. So
in a couple of seconds, we with the small computational resource in Snowflake, we loaded 50 million records from Amazon, unzipped the data, and threw it in.
Yeah, that's true.
So again, my background is in warehouses and databases.
Yeah.
In previous years gone by, 15 million records would have been 2 days loading and things.
Yeah, I had the same experience. So yeah,
it's easy to kind of take it for granted that actually it's loaded 15 million records in a couple of seconds, and we haven't even turned on the speed.
That's true. So again, so as Karen said that you get a computational speed and that too very quickly. So if you want to analyze it, you can go to the history tab and you can see all the queries that you have ran here. So we have just ran this one, that copy into the orders table, take the file from the source and load the table. So you can see that it took us almost like 14 seconds to load 15 million of records. So that's still, that's a very good performance, I'd say. Again, what Snowflake also provides is a query profiler. So if you can click on this query ID, so what you have is a profile for your query. So again, you can see that almost 30% of the time has spent in external scanning to scan the source data. 70% of the time is on the the insert task that it to basically load the data into the table, and again it's a computational heavy task, basically writing to the disk. So most of the time have been went there. And the other interesting thing is that if you can see the external scan, it has scanned 465 megabytes of data from your Amazon S3 bucket, and what it has stored is just 426 MBs of data. So again, it has found the optimal way, and it has stored the database data in a compressed format. So again, Snowflake does it in the background, and it basically saves you space as well, of which you don't have to worry about. So now let's see another interesting feature as to how we can scale up our warehouse, how we can scale up our computing resource on the fly and make use of it. So I also have a line item table. So as I already mentioned that it's like it holds 1:m relationship. So if there's one order, so it might have multiple sub orders, so it's 1:m relationship. And I know inherently that at least it would have same number of records, like 15 million and some more. So now it took us 14 seconds to load it. So let's see if we can, make it faster, if we can load the data, even faster than that, and that too on the fly. So again, we'll do the same steps as we done before. So what I'll do here is I'll quickly go to my stages. So again, I have another folder called line item on my Amazon S3 bucket, which holds the source file. So I'll just quickly create a link to it. So I'll call it S3 line item this time. Schema is stage. URL is IMGS demo data line item. So basically this is the folder on my Amazon bucket which holds the source file. Again, provide your access key and secret access key. So I think we have linked it. If I can go back to my worksheet, and if I change the schema to stage, I should be basically able to see the files that are on my Amazon S3 bucket. So you can see that earlier we loaded 53, we had 53 source file. Now this time we have 150 source file. So again, because it holds 1:m relationship. So let's quickly create a table, a blank or empty table to hold the source file. The third thing we need is a file format, so that Snowflake knows the file format of the source files that we have. So I'll call it line item file. Schema is again stage. So again, we are doing the same steps as we did before. I'll leave it as it is. I know the fields are double quoted, and that's it. So we have created a file format for the source files as well. Now the next thing is what we'll do is we'll scale up our warehouse, or we'll scale up our computing resource to see if we can improve the performance, or we can reduce the time to load the data. So what I'll do here is I click this database that we have created. So sorry for that. You can also, Snowflake also provides a way to see how your warehouse is performing. So, but I'll go to my warehouse. Okay, we'll do it from the worksheet itself. So this is the warehouse that we have. So let's resize it. So let's resize it to large. So again, what I'm doing is I'm allocating extra computing nodes to my computing cluster, which is TPC HDB warehouse. So again, it's instant. You just change it and it's available. So basically these resources are available for your use. Now let's see if we load the line item table, we can do it faster, a bit faster or not. So I'll go to load table, TPCH warehouse that we have just scaled up, source file, and my Amazon S3 bucket and line item. File format is line item file format that we have defined for it. Next, load options, we'll leave it as default and load. So the same step that Snowflake is performing is uncompress it, find the best optimal way to store the data, stores it in a tabular structure, and get some statistics. You can see that it has loaded these many files already. I'll go to my worksheet. If I refresh it, we can see that we have now loaded 60 million of records. So if I can just show you a preview of the data. So yeah, so basically what we have is now the line item table available to us. Now let's see if we have performed any better. So I'll click on the history tab. I'll go to my history, and let's click on auto refresh. Yeah. So now you can see that earlier we have loaded 15 million rows and it took us 14 seconds, but this time we have loaded 60 million records in just 9.4 seconds. So we have basically loaded 4 times the data we have loaded earlier, and that too in half of the time. So that's a massive, massive improvement in performance, and that too on the fly. So this is one of the features with Snowflake and the cloud that you get, that you can scale up your computation whenever you need, and you can scale down whenever you need. So so again, I'll go back to my worksheet, and now what I'll do is I'll quickly create another table to just have a enterprise-wide kind of mimic or the replica of the databases or the tables that you have. So before the demo, I have created using the same step. I have kind of imported a customer table, and I just stored it into another database called AD_IMGS. So I'm just copying the table from there. So again, what you get is the standard ANSI SQL standards that you use with your Snowflake, so you don't have to, worry about the functions or the keyword that you have to use while writing a SQL query. So just the standard SQL queries that you use. So if I again refresh it, so now we have all the tables with us: customers, line item, and orders. Let's quickly just see another feature of Snowflake. So what I have is I have a standard query. This is again from the TPCS Council, and what it's doing, it's kind of joining all the three tables, and it's finding the orders which have generated most revenue within this time period. So again to reiterate that orders table have 15 million rows, line item has 60 million records, so and we are joining all of them together, and customer table has 1.5 million rows. So again, it is kind of, for an enterprise system, it is what you get in real business scenario, and this is, I'd say, pretty heavy query to run on, even though it's a simple join. So let's run it. So sorry for that. So you can see that we have got the orders that, okay, this is the order which has generated the most revenue, and this was the order date for the order, and it took us 1.98 seconds to get 5 these many rows basically. So if I go back to history, and you can see that if I just refresh it took us almost like 2 seconds, and it has scanned like 76 MB of rows to get us the result from the select query. If I run it again, the same query, let's say if I run it again, you can see it just took 147 milliseconds. So basically what I'm talking about is caching. So you can see that what Snowflake is doing in the background is getting the results from the cache rather than going and scanning the disk physically again. So this is another feature where Snowflake does it automatically by default, so you don't have to worry about configuring these caching functionality that you get with traditional data warehouses as well, but again you have to configure it, and you have to assign a pool of physical storage to it. So all kind of thing you have to worry about, but Snowflake does it by default, and it gives the results.
You also need to have
DBA
skills to figure out how to do that kind of tuning and of a database to do profiling of the queries, so they index them and speed them up.
Absolutely, and the other thing is that till the time the data is not changed, Snowflake will give you from the cache. So it has a use case. For example, you are running a report which runs daily, and like user comes and or you might have a report which you refreshes it every like 5 seconds or 10 minutes, and most of the times if your data is not changing, you are just getting it from the cache, and the retrieval is very fast. And the other important, like the benefit is like you are not paying anything for it, because the data that it's getting from cache, no warehouse or no computing resources being utilized. So it's basically you have got a system, you're getting results, and that too you're not paying anything for it as well. So now other thing.
Yeah. So
I'll
come back to me.
Yeah, I'll just quickly hand back to Karen before I move on to the. Basically, before I move on to.
Yeah, no problem. So I just
data sharing bit, yeah.
Yeah, so I was going to reiterate some few points there that thanks to Lydia that we covered. So first off is, you've just seen it, the zero management approach, so that you can load data and run the queries, and Snowflake does all the rest, including the caching, which we just saw.
That's true.
And then is zero infrastructure and admin costs. So again, you know, we were doing administrative tasks there that were being done for us, like the compression of the data. It is secure, so you have to log in. It's highly available. It's fully managed, so no knobs or tuning. And again, as we just mentioned, no indexes or distribution keys or partitioning or vacuuming is needed. It's all done for you. Also, we again, just to reiterate the point, you pay only for what you use. So you can scale up and the computation up and down. You've seen that, how we went from the small to the large. And also we've got the auto suspend and resume. So once your work is done, it'll turn itself off. Where we've got the data will be compressed as it's loaded up, so it automatically compresses the data down. And this provides a really favorable pricing model compared to things like Amazon S3. With also, what we're not going to show today, but we did show at our recent breakfast session, is the ability to load data and bring together diverse data. So with Snowflake, we can actually bring in structured and semi-structured data like JSON, XML, and Avro, and you can even cross-join and cross-query between the JSON and XML semi-structured data and your relational database. And all this is done through centralized storage. And we've got the ability of multi-petabyte scale and being able to query again, as you've seen with some of the queries that I did here, it was running there petabytes of data in seconds. So again, there is that full support for the semi and unstructured data, which can be loaded into Snowflake without transformation, automatically optimized, and then providing high performance SQL querying from any tool. Actually, just going back to a previous point as well, when Aditya was showing in the earlier demo the ingestion of the data from either Snowflake, Azure, or Amazon, actually Snowflake also provide partnerships with other ETL tools. So in the case of ourselves, we can load data up into Snowflake using Talend. There is also partner components inside Snowflake where you can do quick ingestion from things like Fivetran, where you can actually load data straight into the Snowflake warehouse. So they're actually, while we've shown today the simple ingestion from Amazon and from cloud to cloud and from local file, you can also use other ETL integration tools, and naturally we would love you to use Talend. Once that data is brought in, you can then gain insights and support any scale of users and applications. So up to 200 times faster than solutions not built for the cloud. Again, that means you have a consistent service level agreement. So in peak times, you can grow your resources and shrink automatically after those peak times. You've seen already, loading data doesn't impact query performance, and multiple groups can access the same data at the same time with no performance degradation. And so really we support an unlimited number of users, so really is the big data platform. And the final thing we're going to show today, and I'll hand back to Aditya now in a second, is the live sharing, easy sharing of data in Snowflake, so that you can now share data without moving or copying the data from one person to another. It's done through, again, secure, governed, resilient environment with no complex data or ETL pipelines and full data warehouse capabilities. And this is available to all Snowflake customers at no additional cost. So I'm going to give Aditya back the presentation, and he should be able to share the screen and show you the data share.
So hopefully you can see my screen now.
Yep.
Yeah. So as of now, we have seen the data warehouse scaling and the caching functionality. Now we'll just see how data sharing works in Snowflake. So, for example, what I have done here is I am just creating a simple table here, which is like customer_UK table. So I have, as I have seen, that I have a customer table, and I know that I want to share some of the data. Okay, so I want to share the customers who are from UK with one of our manager or someone who is sitting across, somewhere else and has a different Snowflake account, and we want to share this data with them. So to do that, let's create a separate table. So I will create this pretty quickly. So if I again refresh it, public, so the table is ready and it has like 59,000 records, just to show you as to how the data sharing works. If I can just simply run the select query, so this is what we have, like customer names, contact number, and balance. and the market that they belong to. So in Snowflake, we talk about data sharing as a consumer and a provider kind of relationship. So the database that we are using is the provider one, and a table that we will now share with our consumer. So to do that, you can see that you have a shares tab here. So as of now, sysadmin don't have access to make a share available. So I'll switch to the account admin mode. So again, Snowflake provides you with a lot of user based functionality and privileges that you can create and assign to certain users based on the access that you need on the database. So I've changed my type to account admin. I'll go to the share and let's create an outbound share. So basically what I am trying to do is to create a share. So basically to share my table, which is under TPCHDB, with a customer or with a manager who also happens to have a Snowflake account. So I'll select this outbound here. Let's create a share as customer share is the name that I'm giving to it. Oh, sorry. Customer share. Database is TPCHDB. The table that I am interested in sharing is the customer data from the UK region. Select OK. Create share. So now the share has been created. Now what next thing I'll do is to add a customer. So and you can basically define what kind of role you want to what kind of privileges you want to give to the consumer you are sharing the data with. So let's give them a full access, and the account that I have is this one. So basically this is again a demo account that I have created, but again it's a separate schema and it's a separate database, and this is one of the Snowflake basically users available to us. So let's link it. So I have linked the account successfully. So now if I log into my consumer account, so which we have just given access to have resources available, let's do login, and I'll switch again to account admin, who has the ability to see the shares that have been shared across. If I go to share inbound, you can say instantly that the one we have created, we are sharing it with another user on Snowflake. I'll quickly go to I am again on my consumer account. What I am doing is now data has been shared to us. To see the data, what I am doing is just writing this is simple SQL query as to create database customer from share IMGS dot customer share. So if I run it, so you can see the database is created. So I have created a customer database basically, so which will have the same schema as we have of TPCHDB, and the metadata or the database objects we have shared with the consumer user is of customer underscore UK table. So you can see that it now has 59,000 records basically. So if I run this select query, so I can able to see the data. So again, you can see that instantly we have shared data from one Snowflake user, one Snowflake account to another Snowflake account, which is like just instantaneously. Now another cool feature about it is, for example, if you can see here, the consumer who is having access to the data can see the balance, of the customer. Now in a particular enterprise-wide scenario, you want to hide it, or because of the GDPR restrictions, you don't want to make visible this balance to the consumer, or you want to hide it. So let's see if data sharing can provide it, or what we might have to do, because again I will be changing the data in my source account, and then will I have to push the data again, or the updated data again, or it will be available to the consumer instantaneously. So this data sharing also proves, that how easy it is if you have an enterprise system and you have different warehouses with different schemas. So, you have to have the schema, you have to make sure that the schema is same on both the sides, and then you might use some kind of ETL functionality or ETL to kind of get the data from one system to another. But with Snowflake, it's just instantaneously. So again, I'll switch user. So now I am in my producer account. So, and in my producer account, if I run this query, so basically this is the data of the customers from the UK region that we have. So if you can see it, if I can preview the data. So results. Okay.
So well, let's start running that. So the idea of these kind of things is like you could have, like, say, a supermarket chain who's collecting data about their customers and profiling that information, but then they want to share that information with their suppliers. So they might have market trends that they want to share. And of course, we're showing here how you can access the data through Snowflake in the data warehouse.
Yeah,
but people can actually just then stick their own BI or whatever, connect their BI tools to whatever tool. And actually, I think in Power BI, for argument's sake, it has a connector straight into Snowflake, so that consumer can go into Power BI or into whatever BI tool they want to use, connect to the consumer database, and do their analytics without compromising the data.
Definitely. And not only that, you can pick the data from the database, say using Talent. So you can just directly access a table and you can just make use of it. So that's also available. So you can see that this is the data that we have in our producer account. So let's hide, say, just a simple SQL query where I am hiding all the balances. If I can run it, so it says that 59,000 rows has been updated. If I can run it again, you can see that the balances now have been hidden. So in an enterprise scenario, what we want is to have the same view that we are having to our consumers.
Yes.
They should be able to have exactly the same view and the same data that we are seeing. If let's go back on in our consumer account and see what the data is now, because remember now initially we had data same exactly in both the system or at both the accounts level. Now we have changed the data in our producer account basically, and now I'm just running the query in my consumer account. So if I run it again, so you can see that the balance has already been hidden. So now this is what we talk about as hybrid of shared everything and shared nothing database. So what we have is we have a centralized storage, but which we are not kind of sharing, but what we are sharing is the metadata or the objects with the user. So still you can have the same view of the data, but using different accounts, and you can separate your compute from one account to another. So which is one of the cool features of it. So yeah, so that's it. I guess we have seen three features mostly: the data sharing bit, and the caching, and the scaling. And now I'll just
Okay, thanks, Didier. So yeah, we're just coming up to running out of time. So just to summarize, the three things why customers choose Snowflake. So we have performance, so multi-petabyte scale up to 200 times faster and 1/10 of the cost. Concurrency, so multiple groups can access data simultaneously with no performance or degradation. And simplicity, so it's a fully managed with a pay-as-you-go model which works on any data. So again, really is a modern warehouse in the modern world, which is now really moving to pay-as-you-go, and the days of legacy license costs are all gone. Just check now if you are interested in using Snowflake and doing what Didier did today. You can sign up at trial.snowflake.com for $400 worth of free credits for 30 days, and you can select the enterprise edition, and that'll let you do what we've shown today. And if you need any more information, you can go to our website, imgs.ie/data management/Snowflake, and you will see you can get some more information on the product there. Just asking the guys, I know we've only got a couple of minutes. Have we any questions come in on the panel?
We've got one here. Where is the data stored?
Okay, well that's a very interesting question. The data residency is a key topic these days. So again, it's a big concern when people want to move to the cloud of where the data is going to be stored. Is it still in country? The good news is that actually Aditya was running this on the on the Amazon West data cloud, which is actually in Ireland. So you can actually select data residency in Ireland, and you can choose your data storage to stay here or in Europe. I think there's a Frankfurt cloud instance as well. But yes, I think now with Snowflake we have the ability to store the data in Ireland, so it doesn't read. So even though it's in the cloud, you can still keep it in country or within the EU, which is really, really useful. In the background, and Aditya for doing all the hard work in the demo, and we'll finish the webinar today. As I said, if you want any more information, please reach out to us, and also the webinar will be up online on our website if you want to look back on it again. Thanks, Aditya.
Thank you. Thank you, Karen.
Everybody have a good day. Thank you.